In this lab, we're going to examine the water of hydration. So let's look at an example for how to write the formula and how to name a formula. Suppose that we have calcium chloride. And that calcium chloride is a compound. Now, it may absorb water out of the air. Sometimes chemicals do this, and for these chemicals, we call them hygroscopic. Now, it may absorb a specific amount of water out of the air for every calcium chloride formula unit. Now, let's suppose that it absorbs 3 water molecules for every calcium chloride. We would write it this way. We want to put this dot in between the calcium chloride and the 3 water molecules to identify that we have 2 different compounds, but they are combined together. Without that dot in there, it makes it appear like it's all one compound. The water is not chemically bonded to the calcium chloride. We're not changing the formula of the calcium chloride or the formula of the water. And so that dot in there separates the two, but keeps them joined enough for us to know, okay, this is all together in one solid. In this case, we start by naming the name of our compound, calcium chloride. And now we need to add the hydrate part to add that we have water, but we need to say how many waters. So we need to add this 3 in there. And so for this portion, we're going to use the prefixes like we do for other covalent compounds. And we're going to say trihydrate. So the full name of this would be calcium chloride trihydrate. Now in this lab, your job is to identify how many water molecules there are for every formula unit of the compound that we're using, and then you're going to name that compound, including some prefix for the number of water molecules that you find. Now in this lab, you're going to be given an unknown compound to test. It's going to have an unknown ID number on it. Make sure you write that unknown ID number in your notebook because you're going to need to identify which unknown you have. You'll also measure the mass of the crucible and cover without anything else in it. So the empty crucible and its cover. Then you'll put the hydrated sample in, the sample that you have from the unknown. You'll put that into the crucible. You'll get a mass there. Then you'll heat that crucible. As you're heating that crucible, you want to heat hot enough to drive the water out, but you want to be careful not to overheat the sample, as some of those unknowns will decompose if you heat them too hot. After that crucible then cools down, after that first heating, you'll get a mass of the dehydrated sample, the crucible, and cover. From there, you can figure out the mass of the dehydrated sample by subtracting the mass of that crucible and cover. But you don't know, have you driven out all of the water? So you need to go back and heat again. Then you'll allow the crucible to cool again and get another weighing. And if those 2 masses agree with one another, if they're close enough together, then you can say that yes, we drove out all the water that first time. However, if the mass continues to drop, then it's clear that you didn't drive out all the water that first time and you need to continue heating. You may need to heat to a slightly higher temperature, although again, you don't want to heat too hot or you can decompose your sample. So after some number of weighings, it may be 4, it may be fewer than that, it may be more than 4, you will have some data that agrees with previous trials, with previous weighings. And at that point, you can be relatively certain that you have driven out all of the water. You can then figure out the mass of the dehydrated sample. And then from there, well, if you know the mass of the hydrated sample and you know the mass of the dehydrated sample, you can figure out the mass of the water that was driven out by the heating. From those, you can then figure out the moles of water. And then from the mass of the dehydrated sample, if there's no water left, you can then figure out the moles of your compound. Now, this one is a little bit trickier because we have 4 different possibilities here. So here you have to do 4 different calculations, assuming each of the 4 possibilities for your unknown. Then you use those 4 amounts for the moles of your dehydrated sample and the moles of water to calculate a ratio between moles of water and moles of dehydrated sample, moles of the compound. Hopefully, one of those 4 is pretty close to a small whole number ratio. Now, by pretty close, I generally mean within about 10%. Sometimes this lab works a little bit better than others, but again, ideally, hopefully we have one of these ratios of moles of water to moles of our compound that is pretty darn close to a whole number ratio. If you've done this experiment well, you should have a value that is significantly closer to an integer value than the other values. And that one that's closest to the integer value should be the correct compound for your unknown.
So let's learn about how to use the Bunsen burner. We have a striker, and with this striker we have a piece of flint that is going to be scraped against a piece of steel. And if I push just sideways, just this direction, then I don't get very many sparks. But if I push in and sideways at the same time, I get many more sparks. So we want to push at sort of a 45-degree angle using that handle. So let's turn on the gas, and then use the striker to light the Bunsen burner. So in this case, you can see there's blue down at the bottom of the flame, and it's very orange or yellow up at the top of the flame. We want a blue flame. The orange or yellow indicates incomplete combustion, which means we don't have enough oxygen. So we can twist this top part of the Bunsen burner to get more air in at these vents down at the bottom. And so now we're getting much more air in, and so now the entire flame is blue. In fact, we have 2 portions to the blue flame. We have an outer blue cone and an inner blue cone. And right at the tip of that inner blue cone is the hottest part of the flame. Now we have 2 ways of adjusting the flame height. We have a coarse valve using this valve here. And I can increase the size of the flame or decrease it to some extent. And then we also have a valve at the bottom of the Bunsen burner, down here. And rotating that valve will allow the flame to get larger or smaller.
So let's talk about the safety hazards involved in this lab. First is heat. You're going to be heating that crucible, and you're going to be heating it pretty hot. So make sure you're always using crucible tongs when handling the crucible and the cover. Also, all of those unknown compounds are skin and eye irritants. If any of those compounds touches your skin, wash the affected area immediately.